In this video, we're going to start looking at the discriminant. We use the discriminant to find the number of real roots a quadratic equation has, or if you like, the number of real solutions. We will discuss the idea of real shortly, but what we're going to do is start with a quadratic equation. We can write a quadratic equation in the form ax squared plus bx plus c is equal to 0. If we use the quadratic equation to solve this, we could say x was equal to negative b plus or minus the square root of b squared minus 4ac, and this is all over 2a. The discriminant is now the b squared minus 4ac under the root. When we're talking about now finding the nature of roots, or the number of real solutions a quadratic equation has, we're going to have three different scenarios. The first one is that we have two distinct real roots. So two distinct real. The second one is that we have a repeated, or we can say now equal roots. So repeated or equal roots. And the third scenario is that we have no real roots. Let's just look at this idea of no real roots. No real roots means that our solutions will either be purely imaginary or complex. So for example, x might be equal to plus or minus now 2i. This gives us a purely imaginary solution to the quadratic equation. If we had complex solutions, we might have now x is equal to 3 plus or minus 5i. When we're looking at complex solutions, that now is beyond the unit, but when we hear the term no real roots, we have purely imaginary or complex solutions. We will look at these shortly to give you some idea of what's going on. Okay, what we're going to do is just look at this idea of b squared minus 4ac. In your early work with quadratic equations, you would have used this formula to solve quadratic equations. So for example, now if we wanted to solve, let's go for x squared plus 3x plus 7 is equal to 0. If we just look now, the value of a here is 1. So writing these down, the value of b is going to be positive 3 and the value of c is going to be positive 7. We would need, of course, to keep the sign. So if this was now minus 7, c would be negative 7. If I substitute this in here, what we're going to get now is that x will be equal to negative 3 plus or minus the square root of 3 squared, which is going to be 9, minus 4 multiplied by 1 multiplied by 7. What's going to happen here is that we're going to have 9 minus 28. And of course, if we did that on a calculator, which you might have seen, I'll just finish this off, just put this as 2 over 2a, just for completeness. If we put this in now to the calculator, we would come up with the math error. And often it was, you ask, well, why did that happen? The answer is we're trying to take the square root of a negative number. Taking a square root of a negative number will not now give us a real solution. It will give us now these complex solutions. So if I just put in here 2, we'll get now math error. So where does that lead us? Well, it leads us back to this point right here. We can say that if b squared minus 4ac is going to be greater than 0, we will have now two distinct real roots. If b squared minus 4ac is equal to 0, we will have a repeated root. Or, if you like, the quadratic can be written as now a perfect square. So, for example, now, if we had y is equal to x minus 1 all squared, and we graph this, we would see a parabola that simply moved now 1 space to the right. Now, this gives us equal roots as it's touching the x-axis. So in this particular case, b squared minus 4ac, which is the discriminant, we call this a discriminant, would be 0. If we got b squared minus 4ac less than 0, then we have no real roots. We would end up with a scenario like this. Like, for example, now let's just go ahead and write now x squared plus now 4x, and then we will have, let's go on here, plus 10 is equal to 0. Now, if I try to complete the square on this, x plus 2 all squared, then we're going to subtract the 4, add the 10, and set that equal to 0. So at this stage, you can see that by conventional methods, what we're going to have now is a situation where we can't square root a negative number, because I'm going to have over here negative 6. But what we could do now is square root both sides. The square root of negative 1 gives us the complex number I. So we could write now that this is going to give us x plus 2 is going to be equal now to plus or minus the square root of negative 6. So we could write now that x is going to be equal to negative 2 plus or minus root 6i. So that gives us now the solutions to that equation. So we can see this has no real roots because we can't square a negative number and get a real answer, but it does give us now a complex set of solutions. If we'd just taken this here, what we could have done is the discriminant on this. We could have said now that A is equal to 1, B is going to be equal to 4, and C is going to be equal to 10. Again, all of these are positive. So using the discriminant, b squared minus 4ac, we're going to have 4 squared, which is 16, minus 4 multiplied by 1 multiplied by 10. Let's just put 16 rather than 16 squared, 4 squared, 16. And that is going to now give us 16 minus 40, which is going to give me now on here negative 24. So if we had evaluated the discriminant, we would have seen now that we would have had a negative number, therefore there are no real roots. If I took an equation, for example now, x squared minus x minus 6 is equal to 0, on here what we've got is the value of a is going to be positive 1, the value of b is going to be negative 1, the value of c is going to be negative 6. So using b squared minus 4ac, we got negative 1 squared, which is 1, minus 4 lots of 1 multiplied now by negative 6. So that's going to give us 1 subtract now 24, which is 25. So this would have now 2 real roots, 2 distinct roots, as the value of the discriminant is going to be now greater than 0. And the reason I chose that one, if we look at that one, x minus 3, and then we're going to have x plus 2 is equal to 0. That factors, and graphically what we would get here is a parabola at going for negative 2 and positive 3. So negative 2 and positive 3. That's the scenario that we have. If I had now, let's go ahead and look at x squared. We'll go for minus 10x plus 25, and we wanted now to take the discriminant of this one to check if this had real roots. The value of a is going to be 1. It's not always going to be the case. We might have 2, we might have something else. The value of b is going to be negative 10, and the value of c is going to be 25. So b squared, negative 10 squared, is 100, minus 4 multiplied by 1 multiplied now by 25. That's going to be 100 minus 100, which of course is going to give us 0. The discriminant is 0 here. B squared minus 4ac equal to 0 gives us a repeated root. So this is this scenario here. Now if we think about this, we could have factored this now to x minus 5, or if you like, x minus 5 all squared is equal to 0. At this stage, if we were drawing the graph of y is equal to x minus 5 all squared, what we'd have here now is this point here, 5, 0, and that is our repeated root. This is just a graph transformation of 5 units to the right. If we looked at this scenario here, we can see now that we have 2 points where it's crossing the x-axis, therefore 2 distinct real roots. If we looked at the one that we did here, what we're going to end up with is now, if we just sketch this up, our minimum point is going to be at negative 2, 6. So let's put that just here. And that parabola is a positive parabola, and that's what we get. So just completing the square, negative 2, 6, shows that we've got no intersections now, or the x-axis isn't a tangent to this curve, therefore there are no real roots. So that's the take-home message. If you're going to learn one thing from this tutorial, the discriminant b squared minus 4ac is greater than 0 for two distinct real roots. If we have b squared minus 4ac equal to 0, it's a repeated or equal root, or it's touching, in terms of the ones that we're initially going to do, just touching the x-axis. And then if we got b squared minus 4ac less than 0, then we've got no real roots. And we've just discussed b squared minus 4ac is the part under the root of the quadratic equation. This is the form we write it in, and it's fairly easy to evaluate. Later we will use this property. Now when I said the x-axis becomes a tangent, we can use this to solve problems where we have tangents to curves with an equal root as it's touching. What we're going to do in the video is just work through some basic examples, and then in later videos we'll try some sort of exam style questions. Okay, so let's go ahead and look at some of these. Okay, in the first question, state the conditions for the quadratic equation ax squared plus bx plus c equal to 0 to have 1, 2 distinct real roots, 2, a repeated root or equal roots, and 3, no real roots. We've just seen that, and this is something you have to learn, so the more you do it, the easier it is to remember. B squared minus 4ac will be greater than 0, b squared minus 4ac will be equal to 0, and b squared minus 4ac will be less than 0. Nice and straightforward, and that's something to put in your notes and remember. Okay, in question 2, we're asked to sketch a graph of the form y is equal to ax squared plus bx plus c given each of the following conditions. Okay, so the first one, we've got b squared minus 4ac is going to be greater than 0, and the value of a is also going to be greater than 0. So what I'll do, I'll just sketch this up. So what it's saying is show a positive quadratic equation, i.e. the value of a is greater than 0. It's either going to be greater than 0 or less than 0. Quite clearly, if it is 0, we have a linear function and it's not a quadratic. So all I'm going to do now is draw. If b squared minus 4ac is greater than 0, we have two distinct real roots and the parabola will open upwards. So that now is an example. So that's the first one done. Okay. If we look at the next one, b squared minus 4ac greater than 0, yet a is less than 0. So two distinct real roots, but now the value of a is going to be less than 0. That will give us a negative quadratic, but again, we've got two distinct real roots. So there's one distinct real root, there's the other. These, of course, it says sketch a graph. It's not the graph because there are infinitely many of these that we could draw. So positive for the first one, negative value of a. So for example, this one, let's just write this. This might be x, let's go for x plus 5 multiplied by x plus 3 all squared. So what would that give? X squared plus 8x plus 15 is equal to 0 for these particular roots. Yet this one is going to be a negative, so to start off now, the graph, this would be the graph, for example, of y is equal to negative x squared. And then again, we would have now some function of x. So that's what we'd end up with. Okay, let's look at the next one. Right, we've got b squared minus 4ac is equal to 0, and a is going to be now positive. So what we need then is a quadratic equation that opens upward, as a is going to be positive, but this needs to touch the x-axis. So what we've got here is a repeated root, and we've got a positive quadratic. So that, number 3, isn't it? Okay, the next one, b squared minus 4ac equal to 0, but this time this is going to be negative. So all I need to do, I can put it anywhere here, is just now go ahead and draw that. So this again touches the x-axis. We've got now a repeated root, so this might be, we might have this as negative x minus 8 all squared. So this could be the graph of y is equal to negative for quantity 8, x minus 8 all squared. This graph could be y is equal to x minus, let's go for x minus 5 all squared. So these perfect squares will give rise now to the discriminant on here being 0. Okay, let's look at the last two. So this one now, b squared minus 4ac less than 0, so that is no real root. That means it's not going to cross the x-axis. We've got now a positive value of a, so it's going to look something like that. It could look like that. It could be now in the negative the quadrant here where we've got negative values of x. So this one could, let's put that on, that is going to be, which one have we got here? I think we're missing 5, aren't we? So we've got 4 and 6, so that's going to be 6, and then that one is going to be 7. Sorry, that one isn't going to be 7. Let's go ahead and just take that off. We need to do 7, don't we? So that is going to be 7 is going to be the negative one, so that could look like that. So let's put that on. So this one has a value of a that's less than 0, and now on here we would simply graph it like so. We could put it over here. It just means that it's got no real roots. For real roots, we either need to be touching or crossing the x-axis here. As we're not, we've got no real roots. And that would lead now to the purely imaginary or the complex roots to the equation. Okay, let's move on. Let's have a look else what we got. We're asked to calculate the discriminant for each of the questions below and state the number of real solutions to each equation. So let's go ahead. On the first one, we're going to have a is equal to 1, or we're going to have now b is equal to negative 3, and c is going to be equal to positive 5. So b squared, which is going to be 9, minus 4 lots of a multiplied by c. Well, that's going to give me now 9 minus 20, which is going to give me now on here negative 11. So that is the discriminant. Therefore, now b squared minus 4ac less than 0, and we can say no real roots. So no real roots to that one. If we look at the next one, the value now of a is 2, the value of b is 3, the value of c is going to be negative 1. So a is equal to 2, b is going to be equal to 3, and then c is going to be equal to negative 1. So b squared, so that's going to give me on here 9 minus 4 multiplied by 2 multiplied by negative 1. So that's going to give me 9 plus 8, which is 17, positive, so we can write therefore b squared minus 4ac greater than 0, and we can say 2 distinct real roots. So that now would cross the x-axis in 2 places. Let's do the next one. We've got a is equal to negative 1, b is going to be equal to positive 4, c is going to be equal to negative 5. So b squared, 16 minus 4 multiplied by the negative 1 multiplied by the negative 5. So what's that going to be? 16, that's going to be now minus 20, that's going to be now negative 4, therefore now no real roots. So no real roots. Let's just make that a bit clearer. Real roots. As for discriminant is less than 0. Again, I would state this in your working. This would be my working for each of these if it was in an exam. Okay, let's look at D. So on D, we've got A is equal to 1/2, B is going to be equal to 2, and C is going to be equal to negative 3. So if we do b squared, 4 minus now 4, so b squared minus 4 multiplied by 1/2 multiplied by 3. So that's going to give me 4 plus 6. 4 times, we got negative 2, that looks good. That looks like it's going to be 10, therefore now 2 distinct real roots. And again, I'm not going to be writing this here, but if it was an exam, I would do. Okay, so that's that one done. Let's look now at E. So with E, we've got the value of A. So the value of A is going to be equal to 5. The value of B is going to be equal to 3. Here comes the big error. the left hand side now is not set to 0, the right hand side is 6, so we need to write that c is going to be negative, so minus 2, subtract 6, that's going to give me now negative 8. Remember, these must be in the form now ax squared plus bx plus c is equal to 0, so we can evaluate the discriminant. The value of c is not negative 2, as the right hand side is not equal to 0. So that's what we'd have. So we'd have 9 minus 4 lots of 5 multiplied now by the negative 8. So that's going to give me 9. What are we going to get? 160. That looks right. Plus 160. 169. I think that's right. Therefore, we've got now two distinct real roots. Okay, let's look at the next one. What have we got? Okay, with this one, we need to put it in the form ax squared plus bx plus c. So if we do that, just writing out the brackets, we'll have now x squared minus 2x plus 1, and that's going to be equal to x plus 4. So we've got 2x squared, we're going to subtract from that now 4x, we're going to add to that 2, and that's equal to x plus 4. So 2x squared we'll have now minus 5x, then we'll have minus 2 is equal to 0. So we can say that a is going to be equal to 2, b is going to be equal to negative 5, and c is going to be equal to negative 2. So b squared, negative 5 squared is 25, minus 4 multiplied by a multiplied by c. That looks like it's going to give me 41. That looks like 41. Let's check that. 41, therefore again, 2 distinct real roots. Okay, let's go for this one just here. So this one, again, need to multiply it out, set the right hand side to 0. So x squared minus 3x is equal to now 1 minus the x. So we'll have now x squared minus 2x minus 1 is equal to 0. So a is equal to 1, b is equal to negative 2, c is equal to negative 1. B squared will give me 4 minus 4 lots of a multiplied now by c. What's that going to give me? 8. So again, we've got 2 distinct real roots. This one just here, remember, if we drew this graphically now, what we would have is this scenario. We'd have a repeated root. So this point right here is going to be 5, 0. If you are unsure, you could go ahead and expand it out. That would give you x squared minus 10x plus 25, but we can see it's a perfect square. Perfect square will give us now those repeated roots. So on here, we've got now a is going to be equal to 1, b is going to be equal to negative 10, and c is going to be equal to 25. So this is the one we looked at earlier. B squared, that's going to give me 100, minus 4 multiplied by 1 multiplied by 25. That's going to give us the 100 minus the 100, which is 0. Therefore, we can write b squared minus 4ac is equal to 0, and we can say it now repeated. So repeated or equal roots. So I'm just going to jot it down here, repeated or equal roots. So nice examples there. We've just gone through. Hopefully my basic multiplication and addition and subtraction has held true and you understand now. Okay, let's move on and look at something a little different. Okay, question 4. In diagrams 1 and 2, the graphs of 6 different quadratic equations in the form y is equal to x squared plus bx plus c are shown. In part A, for each graph, we need to state whether b squared minus 4ac is 0, greater than 0, or less than 0. For each graph in part B, we're asked to write down whether a is greater than 0 or a is less than 0. Okay, so let's start here. What we've got now, if we just look at this, is a point, and let's just grab up a pen. This point now is going to be touching the x-axis, and we have a positive graph. This graph is opening up. So on this one, b squared minus 4ac will be equal to 0 as we're touching the x-axis or we have a repeated root. And as this is a positive quadratic, the value of a is going to be greater than 0. It's opening upwards. If it opened downwards, then we'd have negative if in terms of a. Okay, this one here has two distinct real roots and it opens upwards. Therefore, b squared minus 4ac will be greater than 0. That gives us the two distinct real roots. And a will also be now a positive quantity. If it was negative, we would have something that looked like so. So go through those 2 points and we'd have that. Okay, this one doesn't now cross the x-axis. So no real roots. B squared minus 4ac is going to be less than 0. Also, the parabola opens downwards, so the value of a is going to be less than 0. So this is a negative quadratic equation with no real roots. Okay, here's 2. So this is a fourth one. We've got now two distinct real roots. Therefore, we can say b squared minus 4ac will be greater than 0. Yet this parabola opens downwards. Therefore, a will be negative, or if you like, a is less than 0. Okay, question number 5. This one doesn't cross the x-axis, so b squared minus 4ac will be less than 0, no real roots. This quadratic is positive as it opens upwards, so a is going to be greater than 0. This one just here touches, so we have a repeated root here. We can say b squared minus 4ac will be equal to 0. It's opening downwards, so a is going to be less than 0. So this is a negative quadratic with a repeated root. Looking at it, that's 5 next to it. This one could well be y is equal to negative the quantity x minus 6. Looks to be x minus 6 all squared. So that is what we could have as this particular negative quadratic. Now it's been translated 6 units to the right. So there we go. That's an introduction to the discriminant. If you just want to take the mechanics way, b squared minus 4ac greater than 0 for two distinct real roots, equal to 0 for repeated or equal roots, and less than 0 for no real roots. In the next couple of videos, we will look at some exam style questions and then take our knowledge a slight bit further.